As soon as you talk about the gut, thinking is not the first thing coming to your mind. You might talk about gut feeling or butterflies in your stomach, but usually people are not asking for the organic correlates of these feelings. And definitely these feelings have to deal with nerves. Nerves in the gut, a very strange thing, you may ask. And yes, there are nerves in the gut. The gut is the place where you can find most of the nerve cells outside your brain. It harbors a nervous system of its own, and we call it the enteric nervous system. This brings up a very important question. Does the enteric nervous system suffer from the same diseases as the brain, such as Parkinson's or Alzheimer's disease? The central problem with these diseases is a far too late diagnosis. It takes decades until the brain is degenerated in a way that deficits cannot be compensated any longer, and the disease is seen by the medical doctor that is treating the patient. With a brain biopsy, it would be possible to see histological changes at very early time points, early enough to start therapies. But brain biopsies cannot be taken routinely. The gut is a completely different story. Here, biopsies are already taken during routine gastroscopies. This was the starting point of a new idea with great potential. A gut biopsy that allows to analyze changes in the enteric nervous systems at very early time points of the disease, thus giving the chance for any early intervention. The most important question here was, is the ENS altered for example, in Alzheimer's disease? We have been investigating this in an animal model and could demonstrate histological changes in the diseased ENS very early. The ENS is a network of neuronal and so-called glial cells, which is significantly altered in the Alzheimer's disease model. There's less nervous tissue, and also the quality of this tissue is changed. The ENS is responsible for a coordinated gastrointestinal motility. We therefore investigated the gut movements and compared peristalsis in healthy and diseased animals. The diseased gut had less strong contractions at reduced frequency. We hope that these first studies are the base for future work by us or others to establish a set of biomarkers for the early diagnosis of Alzheimer's disease in humans. Moreover, we hope to slow down the course or onset of the disease significantly by modulating the ENS environment, respectively its intrinsic immune system. Since, for example, changes in the microbiome in Parkinson or Alzheimer's disease have been described, there's a good chance that the gut might influence the brain also in Alzheimer's disease.